Okay, let's try this again. So in class yesterday, we looked at using the properties of logarithms to take one log statement and to break it up into multiple log statements. Now we're going to take a look at going in the opposite direction, or condensing logarithmic expressions, where we're going to take two or more independent log statements and we're going to put them together using the properties of logarithms. So the same properties that we looked at to take one log statement and break it up, we're going to use to put the pieces back together, if you will, like our Humpty Dumpty logarithm. The answers, after we go through this process, the answer will be one log statement. So just one log statement. So taking a look to refresh our memories, if we have two independent log statements and they are connected by an addition sign, that property implies multiplication. So when we put the information together, we're going to have one log statement, and the information from the two logs will be multiplied together inside that one log function. If we have two independent log statements that are joined by a subtraction symbol, that implies division. And then when we have our one log statement, when we put them together, there will be a division. Notice that the log information that comes after the subtraction goes into the denominator. So any log statement after subtraction is going to go in the denominator, and the rest will be in the numerator. And the third logarithmic property that we have shows that here we have this p, which represents an exponent for the log expression that was put down in front. So when we go backwards, we're going to be taking that exponent here, that p, and we're going to be putting it back up in the place of an exponent. So let's look at some examples here. Just to point out this note here, when we go in this direction of taking multiple log statements and putting them back together again, the first thing we're going to do here, is the power rule. So we're going to look to see, are there any exponents that are sitting down in front that we're going to put back in the air? We take care of that first, and then we will continue to condense or put the pieces back together using the product and the quotient rules. That's going to look like product addition and quotient like subtraction. So let's take a look at this first example here. We have this plus sign, which implies multiplication. So we can put this together, and now we have, notice, two log statements, log, log. We're going to put them together, and we're going to have one log statement, and now it's going to be a multiplication of the information from the two log statements. So it's log 25 multiplied times 4. So we can do this multiplication, 25 times 4. We're looking at the log of 100. Now, we have used the properties of logarithms here, and we're done. We're done with that piece of it. But always we want to keep an eye out. Can we simplify this? So looking at this expression here, remember log, normally we would see a little base there, a number that is hanging down there. We're not seeing that, so we have to remember that that is base 10. So when we don't see a number there, that's going to be base 10. So now the question to ask ourselves, 10 to what power, 10 to what exponent would give us 100? Is there something we can come up with? Yep, 10 squared is 100, so the answer here would be 2. 10 squared gives us the 100. Moving on to the next example here, we have log. Again, it happens to be base 10, but log, and then we have the log of 7x plus 6 minus the log of x. So in between these two is a subtraction. And I forgot to mention here, but I will mention here, we're not seeing any coefficients, any numbers in front of either of these log statements, so there is no exponent to put back in the air, so we can go right to the division. So subtraction implies that it was division. It will be division. So again, we have two independent log statements. We can combine these, and this is going to be LOG, and now this is going to be a division. So we have the 7x plus 6 in the numerator, and now this minus log x is after the subtraction sign, so that x goes in the denominator. So that would be our answer, and we're not able to simplify here. I've written it like this. If you want, you could put it in parentheses if you want to show that all of this statement, this fraction, is within this log function here. Next one, looking at this example, I'm seeing a 2 and a 1/3 coefficients that are in front. So first thing we're going to do here is to put these exponents back in the air, if you will. So here we're going to have natural log x and now x squared. I'm putting that 2 back in position where the exponent belongs. And now this 1/3, so now we have natural log x plus 5, and that 1/3 is going to be the exponent for that expression there. So we put them back up where exponents should be. Continuing on, I'm seeing here that we have an addition sign between those two log statements. And oh, by the way, remember, ln means the base here is e, that invisible e, but we have to remember that. So these individual log statements, we started with 2, we still have 2, but these can be combined now into 1 using multiplication. So natural log x squared, I'm going to put this in parentheses, and now this is going to be times by x plus 5 to the 1/3. So here inside this logarithmic statement, we have a multiplication now. X squared times x plus 5 to the 1/3. Anybody, just in case anybody out there is tempted to distribute this x squared, you absolutely cannot, because this is not a plain x plus 5. This x plus 5 is to the power of 1/3. So you can't do any distribution multiplication here. So we're just about done here. However, there is one final step. This x squared is just going to sit. But now x plus 5 to the 1/3, we know that when we have a fraction exponent, that means that we're talking about some kind of a root, some kind of a radical. So I'm going to write the final version of this answer, taking this x plus 5 to the 1/3 and writing it as a radical. So that would be x plus 5, and now it is the cube root, so I put the little 3 there, and there we are done. So again, I have chosen to put the entire information for the log statement in parentheses to show that all of this is going into this natural log function. You could write it without the parentheses and still be correct.